Alastair Cooper from Cibus. Welcome. Alastair, for those who don't know Cibus, can you just give us a quick pen portrait of your firm? I think it bridges both venture capital and private equity, doesn't it? And it's very focused on food, agriculture.
Yeah, that's right, David. Cibus, we're a specialised boutique small asset manager just focused on investing across the food value chain. We have a very strong ESG sustainable impact sort of ethic. And we have three strategies. We have an operating real asset strategy into high value production and processing. We have a growth equity buyout strategy into the mid-sized companies anywhere across the food value chain. And then thirdly, we have a venture strategy investing into disruptive agri-tech and food tech. We're predominantly based out of London. We've also got a team down in Australia, but we invest globally into the developed world.
Okay, I think we're probably going to talk a bit about three topics. I know it's close to your heart, but probably slightly more, I'm guessing, might be a little bit more venture capital on that side of the fence. We're going to talk a bit about precision fermentation, talk a bit about, we were talking before we came on air, a term that I hadn't heard of called metagenomics. Tell me if I got that wrong. And then robotics. So those are the three areas we're going to cover in the next half hour. Let's start with precision fermentation, Alastair. I would guess that precision fermentation probably has got lost in this whole kind of cultured meat, alternative proteins area. And there is some relationship to it, but it's its own separate area, isn't it, precision fermentation? And arguably, it's probably one of the older scientific disciplines, actually, precision fermentation, for things like brewing, which is precision fermentation in human history. But how does precision fermentation fit into that mix around alternative proteins and cultured meat? It is different, isn't it?
Yeah, absolutely. I think you've characterized it well. Man's been using fermentation for thousands of years. We used it to cure meat. We used it, as you say, to brew alcohol. And then over the last 30 years, it's been developed at commercial scale into what we call precision fermentation, which I suppose is a more scaled and more specific type production system used by many multinational companies. And today, man is using it to produce a range of proteins, nutraceuticals, enzymes used within commercial and the medical world. Notably, products like insulin is produced from precision fermentation. And it's pretty cool because, what man is doing is getting the microbes to do the hard work for us. Yeah. Generally, they're bacteria, microalgae, maybe some fungi, yeast, for example. We're getting them to proliferate at large scale. We're feeding them low value, typically agricultural waste products or very low cost type products. And these microbes have this amazing ability to upscale complexity. So they're taking a simple product and then they're building complexity in the direction that man can now control. So it's a very efficient way of producing the required compounds.
Alastair, I just wanted to give a good example of how listeners might or viewers might understand it. The new technology. So there's lots of these compounds out there to do with guts and IBS. Brands out there, I won't mention too many brands, but like Simprove and all that kind of stuff. That's that kind of area, isn't it? That's the nutraceuticals bit of the equation, which people may run into.
Well, you've slightly gone into a different territory there. Simprove's an example of a probiotic company. So they're actually predominantly providing beneficial bacteria that are generally anaerobic that will then colonize your large intestine, your colon. So that's actually a very different strategy.
Oh, okay.
And what we're doing in precision fermentation is using a microbe to produce the product that we want.
Oh, okay.
And at the end, the microbe is not within the product that we consume. It's been totally removed, or we will have isolated the required compound that we're after.
So give me an example. How might that work? How would you see it in the market?
Well, it would work where, in effect, we will drop into the microbe the genetic instructions to produce the protein that's required.
Right.
So the microbe will then do the hard work. It will assimilate, via our feedstock and produce, using this genetic information, the protein or enzymes that are required by man as a form of enzyme, maybe nutraceutical or protein that we can then use. And to give you an idea, I mean, there are now companies, you might have heard of Perfect Day on the West Coast, that has engineered yeast to secrete casein and whey, i.e. the proteins that are in milk. So now we're producing, in effect, dairy products without the need to raise cows. The Every company has engineered yeast to secrete albumin, i.e. the protein in egg white, so we can produce, in effect, eggs without the need to raise chickens. But what's happened recently is synthetic biology has elevated precision fermentation that's been around for 20, 30 years to a totally new level. Both a new level in terms of efficiency, but also a new level in terms of the breadth of products that can be produced. And synthetic biology is sort of taking the old world of GMO, then the more recent world of gene editing, and it's taking it to the next level. So synthetic biology is actually rebuilding entire metabolic pathways within these microbes to do what we want. I'll give you an example. We're invested in a company called DMC, which is based in Boulder, Colorado. DMC stands for Dynamic Metabolic Control. And this company has engineered E. coli bacteria. It stripped out basically non-essential genetic information within the bacteria, can get the bacteria to proliferate and silence all the other genes. So all the energy is put into proliferation and nothing else. The E. coli then builds enormous scale within a vast precision fermentation tank. And then DMC can send that E. coli a message. And they can switch off the proliferation genes and turn on the secretion genes. So the microbe at this point no longer wants to proliferate, which is normally genetically encoded in every organism in the world. And instead, it just puts all its energy into secretion. So DMC is now getting precision fermentation efficiencies of 60 to 70%, whereas traditional precision fermentation efficiencies are only, say, 30, 35%. So way more efficient production. Now take this on a stage. Their first product range is going to be essential amino acids. Amino acids essential in animal feed and human feed. Today, the world is reliant on these amino acids to be produced by the Chinese using chemical synthesis. So this is a way of taking the production of essential amino acids to the West, producing them via biofermentation rather than chemical synthesis at 1/20th of the greenhouse gas emissions, and giving security of supply to the West. So it's that type of product. But essential amino acids is just one of an incredibly wide spectrum of compounds you can now produce because you can rebuild these whole metabolic pathways. And that's why I think many of us are very excited with precision fermentation and synthetic biology. It's incredibly efficient in terms of greenhouse gas emissions. And obviously, these precision fermentation plants are scalable anywhere in the world. You need a very low land mass. You recover all the water, you recover all the heat, and you're feeding the microbes literally waste products. So it's a really exciting new direction.
And could that technology be deployed in other areas? We've talked about food-related areas. Could it be deployed in non-food-related areas? I mean, could it be used to produce, I don't know, in the energy complex or anything like that?
Yes, it can be used. It's going to be used in many different areas. It's going to be used for biofuels. It's going to be used for a whole range of foods. It's going to be used for replacing compounds that are derived from unpleasant chemical synthesis routes by giving a sort of healthy biofermentation route. So it's going to increase sustainability and generally supply of a vast range of compounds.
And we just touched on synthetic biology here. That's sometimes it's been a bit like sometimes nuclear fusion. Everybody says it's going to produce these amazing results, and we keep waiting. I'm old enough to remember when, was it Craig Ventnor did that? Was it the first synthetic organism, synthetic living creature? Are we finally seeing synthetic biology begin to have commercial applications now?
Yeah, absolutely. I mean, the products are on the market today, at scale already. The big multinationals, the DSMs of this world of Novozymes, et cetera, they're in the thick of it. But there's a plethora of exciting young venture companies focused on this space, attracting quite sizable amounts of capital. And it's a really exciting disruptive area.
Talking about technology, let's talk a bit about, I mentioned it earlier, metagenomics. Now, that sounds very biotech related. Sounds like we're basically focused on drug development. But what's its application around the food and agricultural complex? And just talk us through, what does it actually mean?
Well, I think the world of metagenomic, I think it's generally known as metagenomic data mining, is creating enormous excitement. It's been enabled by the scale of DNA synthesis that we can now conduct at an incredibly cheap price. Mm-hmm. And it's been enabled by specifically Alphabet and Meta's releases in the last year. Yeah. You're probably aware that Alphabet's DeepMind released a product called AlphaFold just under a year ago, which was about 220 million protein structures of basically known proteins. And that was followed later last year by Meta's AI area called ESM Metagenomic, releasing 617 million predicted protein structures. And this covers a whole range of bacteria, viruses, and microbes that have never before been classified or investigated in any way. And what we're excited about is you can now take and sort vast amounts of DNA in a way that we've never been able to do before. And your DNA, as you know, is basically, it contains the codes for your 20 amino acids. And these amino acids are then assembled into chains, often very complex 3D structures known as proteins. And those proteins are the building blocks of life. So metagenomics is the study of genetic material recovered from the environment around us.
Right.
I'll give you an example. A spoonful of soil may well contain 100 billion organisms of 1 million different species. This provides, obviously, a vast amount of DNA, of which only a small fraction we know and have ever genetically sequenced before. The vast majority has never been classified. Another example would be our gut microbiome that harbors maybe 20, 30 trillion different microbes in all of us. And obviously that has a mind-blowing variety of bacteria, viruses, and fungi.
And what do you hope to find? That bit of soil. Are you looking for compounds or amino acids or whatever that we could use, or is it farmers looking for big data, understanding what's in their soil?
I'll tell you exactly. What we're doing is we're taking these latest sort of data analysis techniques at scale, and we're able to identify segments of DNA within these metagenomes, such as the soil or the gut, that have never before been sequenced or seen. And then we're taking them to the AlphaFold and Meta work, and we're then able to predict a whole new range of proteins and protein structures that have never been seen before. Man has never seen them. So these are a vast range of new proteins, and we're then taking those, and that is allowing us to then develop a whole range of new solutions for food, health, or even biomaterials. So examples would be a new enzyme that will increase biological reaction efficiency in fermentation, or a new antibody that aids human health, or a new protein for farming that perhaps increases nitrogen uptake in our crop plants. So it could be a really wide range.
So to use a metaphor, I mean, back in the 19th and 20th century, we went prospecting in the jungles and found all sorts of remarkable medical finds. We're just doing this not in the jungle, but in a genomic
This is exactly the same thing. We're invested in a company called Mycotechnology as an example, which is mining the fungal universe. Fungi, as you know, have provided us with the majority of antibiotics. But we haven't had a new antibiotic class discovered since 1987. There's 2 million fungal species that we're aware of which only 150,000 have ever been described. So this is about, as an example, mining that fungal database to derive new pharma and nutri products. It's really exciting.
Presumably, you could also use it, though, I mentioned earlier. I mean, or is it just too expensive at the moment? If a farmer has got a very rich farmland to understand what's in the farm structure? Or is it just too expensive? You wouldn't do that?
You're absolutely right. This is about, the trend will be towards personalization.
Yeah.
It could be taking a sample from your gut microbiome and really analyzing in a way we've never been able before, and then tailoring for you and your lifestyle and your health position, the perfect combination of lifestyle, nutraceutical and products for you. It could be going to a farm, analyzing that soil, and then optimizing for that farm and that soil, the inputs, the genetics, etc., that would be most beneficial for the production.
I presume you just go back to the metaphor. If you did it in the Amazonian jungle, you probably wouldn't get a couple of million. You probably get a couple of billion.
You absolutely would.
Okay. Now that leads us on to the last one, I suppose. It's robotics. You and I have talked a bit about robotics before, and I suppose if there is anything in the popular imagination in the whole field of agricultural robotics, I suppose it might either be a GPS-controlled tractor, or I know have invested in strawberry picking robots. What's just explain the rationale about why you think it's going to change agriculture? Because I suppose just to the one question I suppose a lot of people have is they go, I get why you get robots, but they are expensive, and most farmers. I live in a rural area. Most farmers have only just recently upgraded their tractor, which has cost them a fortune. So are they going to be able to afford to buy strawberry picking robots or GPS controlled robotic tractors? One gets the functionality and labour, as we both know, is very difficult for many farmers these days, particularly with things like fruits. But without the cost, won't the technology rub up against the cost?
Yeah, I think you raised some good points, and I think cost has been a bit of a stumbling block historically, but I think that's starting to change very fast. Right. I think we see robotics as addressing a number of issues, of which you've kind of highlighted one in the main. I think on one hand, robotics is going to replace big, heavy farm machinery with small, lightweight robots that are electric rather than gas guzzling. It reduces soil compaction, etc. The robots will use visual recognition technology and sensors to collect data, to optimize that, manipulate it, and minimize inputs. But again, the robots will address this issue of labor risk, which you've highlighted. And across the Western world at the moment, young people don't want to work on the farm. It's a massive problem. It's not attractive to get wet, dirty, bend over, double in heat. So it's becoming very critical. So we see robots being applied, in all of these directions. And I would say much of the time we're seeing a financial strategy where robots are offered as a service. They call it RAS, RAAS, robots as a service.
Okay, fine.
So what is designed to happen is the robot will be offered at the equivalent price of your standard picking or application that you would have. But it's taking away that risk. And over time, as the robots build scale, they'll be offered cheaper. So, for example, there are robots now that, as you say, pick strawberries, pick fruit, and you literally the farmer just pays the cost per kilo of that production as he would in the normal way using a grower. But the robot obviously can do it 24/7, day, night, doesn't have stops, doesn't have tea breaks, and can often optimize it and then collect data at the same time.
So this is not too dissimilar to the model where a farmer might buy a combine harvester. Excuse me, I coughed away. A combine harvester and rent it out by the hour or the week.
That's right.
Sorry.
Yeah, in farming, as you know, there are many different financials. Styles. There's obviously a lot of contracting done by large contractors who, in effect, are sharing machinery over a number of different farms. Many farmers in the Western world like to own their own kit for some reason. It's a kind of male problem, I think. Big kit ownership, and they, on the whole, are used to getting cheap loans to do it. John Deere with some sort of zero interest rate type loan to do it. But we think generally robots to begin with will be offered as a service, as I said, and that will help get over some of the financial hurdles. Now, what we're seeing is because the cost of inputs and the cost of labor is escalating, the ROI, the return on investment for the robotics is becoming more and more attractive.
Right.
So I think that's going to be one of the drivers of it. We've got robots, for example, a very simple robot. You talked about expense. We're invested in a company called Burro, B-U-R-R-O, the Spanish word for donkey, which is based in California. And it's the simplest robot on the market. It sells for just sort of $13,000. And it helps out on the field in the grape and fruit world amongst pickers and packers, and it reduces the need for labor by about 30%. It's giving the payback to the grower in under 3 months, as an example. And that's a world, obviously, where labor costs are escalating fast and labor supply is becoming more and more inconsistent. So it's really providing a pretty cool service. I'll give you another example.
We'll almost be having a gangmasters full of robots lurking around the countryside. That model is a completely bonkers idea.
That is the direction things will go, and it's enabling the farms to be restyled. So it's interesting in these table grape farms, is allowing them to plant table grapes in rows of 400 meters instead of 200 meters, because the robot will do the hard work going up and down the road rather than the humans, as an example. But it's also being used in different directions. For example, with climate change and global warming, we're getting more and more fungal disease in our crops. It's a big problem.
Yeah.
In Europe, 60% of all fungicide use is used on grapes. 60%. It's a massive problem, powdery mildew and downy mildew. We've got robots now that have ultraviolet light mounted on them that go up and down the rows of grapes or strawberries at night, and the ultraviolet light kills the mildew, 95%. So this is a way of significantly reducing, for example, fungicide use. So robots are providing that as a service, not just on price, but also to appease new regulations and the requirements by many of us, to reduce synthetic chemical use, as a great example. We've got another strategy we're just looking at, which is in the world of precision spraying. Your spraying today by the conventional farmers is obviously done at scale. It's done totally indiscriminately.
Yeah.
Now we have spray booms with visual recognition technology that identifies weed from crop plant and allows targeted sprays of just 6 centimeters by 6 centimeters. Either green on green, i.e. weed plants within grass, for example, or green on brown, which means weed plants within bare soil. And then you can reverse it the other way, and you can target the crop plant itself rather than the weed. So this enables you to use high-value new micronutrients or biological products, which you could never use before because you had to use so much of them. Now you can use a small amount in a very targeted way on the crop plant itself. So we see it as an enabler of a whole range of new, exciting biological products that will replace synthetic chemicals.
I just want to finish off with just a couple of kind of quick-fire questions about other stuff we've seen in the media recently in the whole kind of in the agtech field and foods. What's your take on vertical farming? At one stage, it was very hot. People got very excited about it. I noticed the Gulf states are still extremely interested in it. You've been tempted to look at that area because it is interesting.
Yeah, I've personally looked at it for 15, 20 years. Our first ever investment at Cibus in May 17 was in a company called AeroFarms, which I still believe is a premier company in the space globally. Absolutely. And I'm on the board of AeroFarms, so I'm slightly biased, of course. What I can say is vertical farming is really tough, tough. There's an enormous amount of companies out there. We probably see a new one every week. I think the majority of companies will go bust. But there will be quite a few winners over time. And vertical farming, I think, is a strategy whose time has come in that recent focus on the need for food security.
Yeah, absolutely.
On the need to improve resilience within our food value chains has really focused the mind on moving the point of production next to the point of consumption and giving that security. So the area that you're talking about, the Middle East, we're seeing particularly strong interest. Era Farms has announced a deal with Saudi, for example, a joint venture to roll out farms across the Middle East. And that area has obviously got a lot of capital, very focused on food security, and it makes a ton of sense. And I almost think that the Middle East will actually facilitate the growth of vertical farming at scale, allow further economies in scale, and actually probably allow it to then come back to the Western world in a way we don't expect.
Either that or some of the city-states in Asia, Singapore particularly.
There's enormous headroom, there's enormous speed of progress in vertical farming now with genetic progression. Because remember, originally with vertical farming, the genetic stock being used was obviously designed for open field growth. Yeah. Whereas now we're able to evolve genetic stock very fast that specifically responsive and designed for the vertical farming world. Era Farms' last plant that they've just built in Virginia in the US is almost totally robotic. So it's auto seeding, auto movement, auto fertilizer and spray. It's auto harvest, auto packaged at a scale we've never seen before. And is actually, we believe, the first profitable vertical farm in the world. So it can be done. And remember, it's using 95% less water than field grown, 90% less nutrients, and 0 sprays. And then actually the other interesting thing is, David, people tend to forget is, because this environment is so clean within the vertical farm, at the point of harvest, the product doesn't have to be washed, doesn't have to be washed in chlorine, which other salads do in the US. And it has very little bacteria on it at that point. So it means the shelf life of the product is much longer. And Whole Foods is distributing Era Farms products across the US now and has proved a 15-day shelf life, which is unheard of for a salad product.
Yes, quite a lot.
Just because it's so clean. And then the other aspect is, in a vertical farm, you can basically stress the plant for the outcome you want. Yeah. If you want more vitamin C in your rocket, you can have more vitamin C. If you want your rocket more spicy, you can make it more spicy. So it's a way of actually really embedding higher nutrient density and taste, as well as longevity. It's pretty exciting.
I suppose the only problem is it's also capital intensive, which is...
It's capital intensive, and the cost of capital has gone up, absolutely.
Yeah,
and
absolutely.
There's no doubt, and you've seen, as I have in the last year, there have been a number of companies that have gone to the wall because of that.
Yeah. The other one I wanted to mention, which actually you've already just touched on, is plant biotech. I was very interested. I heard an interview with Tyler Cohen, who interviewed the guy who founded Moderna, and he was chatting away to him and asked him what he thought was the most interesting area coming. And his view was plant biotech, that we could effectively re-engineer plants to do things that we want them to do differently. We've already sort of touched on it already. I mean, bits of that almost follow into synthetic biology. You've already mentioned it with Aerofarm, just taking a more engineered variety of seed or plant and using it for a particular purpose. Are you seeing much activity in plant biotech? Now, of course, this obviously borders into the whole GMO debate, which was kicking around a while ago. So there's that. But GMO was about, correct me if I'm wrong, was about introducing genetic information which was alien to the original plant, which you then added onto it. Whereas I think a lot of plant biotech, they're actually looking at refining or changing. What are you seeing in plant biotech? Anything interesting?
Yeah, we're seeing an enormous amount of a focus on this space. And as you say, GMO is transgenesis, i.e. introducing a foreign organism's DNA into that plant. Yeah. Generally, plant biotech today is gene editing. So it's using, it's more like taking a scalpel to that genetic code and knocking in or knocking out a specific gene. And we're seeing many companies in that space. It's generally taking a little bit longer than people expected to reach commerciality, which is causing some problems in terms of cash burn and some issues around funding. But I think the direction of travel is undoubtable. And what is happening is man now can design and develop traits of plants in a way we've never been able to do before. So this is about driving plants to be more resistant to water shortage, more resistant to temperature, perhaps having more sugar inclusion within a strawberry. It could be an all-seed rape, so the pod doesn't shatter at the point of harvest. It's specific traits like this. And on top of, shall we say, manipulating the genome directly, the world of epigenetics, which is about stressing the plant, for the outcome that you want, is also sort of layered on top of it. So it's a sort of complex interaction of the two, which I think is starting to bear fruit, which is very exciting.
Are you seeing much that's investable at the moment, though? Or is it still, as you say, there's this runway problem and they're not quite there at takeoff yet?
I think there's many companies utilizing it to a degree within their business plans. So, for example, AeroFarms would be doing work around this to improve genetic progression and also around using plants as mini bioreactors in their own rights. So as we spoke about earlier, using microbes, you can also use plants. Nicotinia, the tobacco plant, has long been used in the medical world for a range of different drug production. But now we're also seeing plant cells being cultured within a reactor in a way we never have before and getting them to produce different products. They have the ability to produce ranges of more complex products that microbes can't sometimes, which is quite interesting as well. So it's a really interesting area.
One very last question, and then we'll finish. I want to just talk very briefly. The whole kind of alternative proteins and plant-based alternative proteins has had a bit of a rough ride in the media in the last couple of months. Come under a lot of attack. There's a very big brand, which we won't mention, but we all know who it is, whose share price has gone down quite drastically. And there's been a lot of negative publicity around the whole kind of plant alternative protein area. And I suppose many people have always worried about it being commodified and all that kind of stuff. Do you think it's probably now a bit, for venture capitalists, a bit untouchable? Do you think that whole kind of plant-based alternative proteins is tricky?
Yeah, I think we're always a little skeptical about the B2C side of that space. Valuations to us weren't attainable. The Beyonds, the Oatley's trading at 10, 20 times revenue wasn't something we could ever justify. And it was a crowded space. And what we saw, obviously, was the early adopters loved it. They piled in. Growth rates look great. But that momentum's gone, as you've highlighted. And there's a few problems. One is the cost was too high. Two, generally the taste disappointed to the average consumer, and it didn't compete with the sort of indigenous products, as it were. And three, they turned out to be pretty processed, relatively unhealthy products on the whole. So it didn't hit any of those spots. So what we're seeing, what everyone's now working on is clean label, great tasting stuff at the right price. And that's the only thing we would invest in. We need price parity, we need clean label, and we need an equivalent taste. But what I would say is there's some areas that are exciting. I'm afraid I'm going to have to mention a couple of our own investments. One is a company called Future Meat that's just rebranded as Believer. Investors in it are the likes of Tyson's and Archer Daniels at scale. And they're just building a very large plant in the US to produce initially what's called a hybrid product, which is a mixture of cellular fat and muscle with extruded plant protein. Now, that may not sound that appetizing, but I can tell you it tastes amazing. And when man eats meat, all the sensory benefit comes from fat, smell, taste, aroma. Muscle itself is just protein. It has no taste. So remember back to one of those Beyond Meat burgers you might have tasted. It really was a pretty disappointing experience. But imagine putting healthy beef fat into that burger. It elevates it into a totally new level. And I've eaten Believer's new chicken product and lamb product, and I can tell you it was indistinguishable from the real thing. And this is 50% soy protein and 50% cellular muscle and fat, and it's just a fabulous product. That'll be on the market within a year at a comparable price, and I think will change the face of that whole product group.
Okay, Alastair, I've had enough of your time. Thank you very much, Alastair Cooper from Cibus.
Thank you.